Two innocent looking balls. But when they collide, what happens? Let us see. Wait, why am I showing you this? Wasn't it supposed to be interesting? Now let me tell you something which will make it interesting and ruin your sleep. All the balls after colliding go out at 90°. See. It works not only for balls but any circular shape. Isn't this amazing? I was mind blown myself when I first read it. In fact, I didn't even believe it until I tried myself. You can try it too. But you must also be curious, why does it happen? Why do they only come out at 90°? They could come out at 30°, 0°, any angle. In fact, common sense tells us they should change for every angle at every point. Then why doesn't it happen? Let us take the help of science for that. It is also one of the favorite questions of physics high school textbooks. So it goes something like this. There is a ball of mass m and another block of mass m. Both have the same mass. So we need to prove that when this ball collides with this block, then they go in perpendicular direction, like this. Most textbooks have proofs involving trigonometric divisions and such, which are not very intuitive. But a simple change in a frame of reference can make it much easier for us to understand. Let us turn the ball and the block a little, like this. Now it becomes much easier. After changing, the collision will look something like this. Can you see what has changed now? Now it becomes much easier for us to understand what is happening. You can see that the ball and the block are moving at right angles. Like this. Aren't you curious about why this is happening? Let us try to understand that intuitively. So the ball is going diagonally, right? So we can divide it into two parts. One of them will be the y-axis and the other one will be the x-axis. So when the ball moves, these will map its x and y coordinates. Let us first take into consideration only the y-axis. So we remove the x-axis for now. When the ball moves, you can see what is happening, right? When this moves, the y-axis stops here and the block keeps moving downwards. Why is this happening? Let us remember a point from one-dimensional collisions when two bodies of the same mass collide. When a bouncy object hits another bouncy object, it is termed as an elastic collision. So when the two bodies are of the same mass, then let's see what happens. Yes, so this is what happens. The ball which was moving stops moving, it stays at the point. And the ball which was at rest, it moves with the same speed as the original ball. This is known as transfer of momentum. Now try to relate what we just learned. See the collision now. Doesn't it strike you what just happened? Take a look at the y-axis, what the y-axis is doing. Now I'll remove the original ball so that you can see what is actually happening. Can you see what is happening? Isn't it the same as what happened in the previous animation with the collision of the two curves? That is exactly what is happening. So the ball strikes down, the y-axis of the ball stops there and the block keeps moving downwards. Let's see what happens to the x-axis. It's very simple actually, nothing happens to it. It just keeps moving on. There is nothing to stop it. Now since we understand both the axes, now it will be easy for us to understand what is actually happening in general. So the y-axis stops moving, the x component still moves, and the y-axis's energy is transferred to the block. Isn't this property cool? So much for two simple looking balls. You can use this property while playing billiards to impress your friends. If you found the video cool, make it cooler by commenting. Thank you.